what percent of the molecules we use are chiral? The answer is a significant percent, but not all. Chirality is based on being able to have 4 different things around a single center. And carbon, which makes 4 bonds, if it attaches to 4 different functional groups, will be chiral. Since we traffic in carbon molecules, we're quite chiral. But not everything is chiral. So some things escape that standard because they're constructed in a way where chirality is not possible. So the theory is like this. You need 4 things to be chiral. Carbon can obtain 4 different things around it. Most organic molecules are carbon-based, though not necessarily chiral, because they'd have to put 4 different things around it. Now let's think of some common structures. Carbohydrates. Why would they be chiral? They have a lot of repetition. The carbon is surrounded by another carbon, by another carbon. So as soon as you have 2 similar things surrounding the carbon, there's no question of chirality. Sometimes chirality affects just the tip of a molecule. And maybe that tip isn't chemically active. Sometimes we have diastereomers, things that have 2 chiral centers. So the isomer question, isomer means 2 things that are equal, isomer, equal parts, but spatially arranged different. The chiral things are isomers of each other. The isomerism question is very, very popular in organic systems because they're governed by carbon, and carbon can obtain an isomeric form. But it doesn't have to obtain that form all the time. The notable chiral things are some of the vitamins, lactic acid, a component of the skin, ascorbic, you want L-ascorbic at all costs, the amino acids, which is where most people already traffic in L. In the amino acids, that's where even the lay people know it's L because they've always been so, they've always been represented that way. It's just the way they're taught, actually. In biochemistry, when you finally get introduced to amino acids, L starts to be part of the nomenclature. L-lactic has interesting properties in the skin. L-lactic can both exfoliate the skin and moisturize the skin. And it has this dual role because it can attract water, and it's believed to be involved in a number of pathways, including things that can create gags, which are like the hyaluronic acids and the things that themselves retain water. So truth be told, the literature has not solved the problem of how lactic acid exactly interacts with the skin to do its wonderful things. But the observed effect is that it can both desiccate the skin, dry it out in a high level when it's in its most acidic form. And this brings us to another thing called the pKa. The pKa has to do with acid chemistry. This is a bit detailed, but it's relevant. When you have an acid, it means it donates a proton. And how many protons it's donated determines its acidity or not. And that gives us the pKa and the pHs and so on. pKa is a measure of how acidic an acid is at a moment. Because you can have different concentrations of acid. It's not always as potent, right? And so basically, in its most potent forms, the lactic acid acts as a desiccator. And that helps exfoliation because that's the whole point of peels, is you dry the skin, you rip it off in a sense, you cause it to die, and it falls off, and then more skin gets produced. But if it's in its less acidic form, it actually attracts moisture and contributes to a number of pathways that make the skin more moisture, more water retaining. So it's a very elegant molecule. It's probably the best strategy for the exfoliation. You could also move over to the secondary acids like the salicylics, which have more complex chemistries and are not so aggressive. But lactic acid has its place in skincare because it's already recognized by the cell if it is in its L form. If it's not in its L form and you present the skin with a mix, you'll have to use much lower concentrations because you essentially have a potent exfoliant on your hands, which really means a potent killer because that's how you exfoliate. You pretty much dry things out. And you don't want to have that around too much.